to configure lower layers. How RRC should work, that is fixed. How mobile's RRC should work, how GNodeB's RRC should work, there is nothing to be configured. RRC itself talks about lower layers. RRC talks about how SDAP should work, how RLC should work, how MAC should work, how physical layer should work. So if RRCs are exchanging the messages, they are talking about lower layers. Got that, Pawan? All right. A lot of you are not sharing the webcams yet. Not in. We are losing the time, guys. I don't have time. We are lagging behind 2 subjects. Okay, so I've already decided to drop some subject parts, but now you are making me to lose some more. Okay, please complete your things fast. Let us continue. Pratisha, please take care of that webcam part. All right. RRC procedures. First of all, what is a procedure? A procedure is you can generically define it as some set of RRC messages getting exchanged between UE and GNodeB to achieve some functionality, to do some job. And how many messages are part of this procedure? It could be 1, it could be 2, it could be 3, it could be n number of messages, depending on the situation. In different procedures, different number of messages would be present. Need not be equal always. One procedure may contain 3 messages, other procedure may contain only 1 message, other procedure may have 2 messages. So it changes from situation to situation. For example, if you take it in the form of a diagram, it looks like this. So UE is triggering a procedure towards the network. Every time it is represented as network, you have to understand that it is GNodeB. Because GNodeB is the boss for the radio network. So we simply call, instead of writing here as the network, we put instead of writing it as GNodeB, we are keeping network as the word here. So we have the trigger message sent from UE, for which network is sending a reply, reporting about whether it is accepting a corresponding message or rejecting it, whatever. Maybe mobile, if it gets a proper reply, a positive reply, it may respond back with procedure complete. Hey, thank you very much for replying back and supporting me, helping me out. You are a really good guy. I'm praising you. So send this complete message. So this is example with the dummy messages. These are not actual RRC messages. Just to make you understand what is the meaning of a procedure. Is n number of messages that are getting exchanged between the mobile and network to achieve a particular job or functionality. So now what we are going to see is, we're going to see several different procedures, after one procedure after the other procedure. For every procedure, I will introduce what this procedure is going to do. What is the purpose of this procedure? Why the messages that are in this procedure are getting exchanged between the mobile and GNodeB? What these messages after achieving, getting exchanged, what do they achieve? What is the purpose of the procedure? So there is always a purpose for every procedure. So when I'm introducing the procedure after procedure, so we'll be studying 13, 14, 15 procedures in RRC. For every procedure at the starting, I will be telling you what is the purpose of it. And then I will explain what and all the different messages that are involved in that procedure. And in each message, what happens? What is the substep that happens? I will explain that. So you have to remember everything in terms of procedures. So everything about RRC is procedure based. So the first one that we are starting is system acquisition procedure, which is done by your mobile phone. Now, as you can see here, all those arrows that you are observing in the network, so that's your that's the number of steps that are part of this particular system information acquisition procedure. Mobile first need to get master information block from the network, MIB, which is the important block of the system information. The main part of the system information is MIB. We already have studied that MIB as part of SSB block learning. After that, mobile will have to get system information block 1, or in shortcut, we call it as SIB1. So the first letter of each word, SIB1, SIB1, which is called as. So mobile need to acquire SIB1. SIB1 will give the clarity to the mobile. SIB1 will get lot of technical details to the mobile that are required for the mobile equipment to operate in this cell. It will contain a lot of technical details, like for example, different aspects of physical layer, MAC layer, RLC, PDCP would be explained in this SIB1. May not be PDCP, but other layer related aspects will be explained. What details would be explained, we'll see. But definitely it will carry some important system information. But also this system information block 1 tells the mobile how the remaining SIBs are going to arrive. Your system information is divided into many blocks. For example, you have SIB1, SIB2, SIB3, SIB4, SIB5, 6, 7, 8, 9, 10, 11, 12, 13, 14, up to 40. Actually, up to 24 we have. But at least important ones are up till here. Now, this SIB1 tells the mobile how the other SIBs are going to arrive. Whether the other SIBs are going to be distributed continuously 24/7 in a broadcasting fashion by reserving some particular spots for them, or network is asking the mobile equipment to demand for the system information. So what the option that is configured in the network side, it will convey the detail to the mobile, how the remaining SIBs are going to arrive. For example, if the network tells the mobile that, hey, you must request for the rest of the system information details that based on your need, then mobile will have to send the system information request to the network, asking or begging the network that, hey, I'm looking for so-and-so system information, send me. Network will schedule that system information with the help of some RNTI called as the SIRNTI on the PDSCA channel and send that system information to that UE, and which mobile would download that system information. So this is applicable for all the system information blocks other than SIB1 and MIB. But this middle part, this middle one is basically kind of optional, this system information request. It is actually speaking optional. For example, if network tells the mobile that, hey, you don't need to request for the system information blocks. I have configured all the SIBs in a continuous repeated fashion. So this is the timing where everything will arrive. It will provide corresponding details in SIB1 itself. So in that case, UE doesn't require to send this request. Instead, it will simply wait for the corresponding occasion where the remaining SIBs are going to arrive, and it will download the SIBs one after the other. So in this case, this message won't be there from the UE. So in that particular scenario, it is this entire system information acquisition procedure is unidirectional acquisition procedure happening in only one direction. It is only happening from the network to the mobile. There is nothing that the mobile equipment is reporting to the network. If it is not there, but how does this work out? How does mobile decide whether to send a request, or if it need to send a request, how it send a request? For that, we have an algorithm of how mobile should work. Mobile switches on and start doing something called as a cell search. Start finding out how many cells are present in this particular locality. And the moment it finds out a particular radio frequency, it thinks that it found out a cell. On that particular radio frequency, every 1.44 megahertz, by skipping it, it will start looking for the PBCH. It will start syncing to find out SS block. And then it will, on the SS block PBCH, you will get your MIB. You will download and decode the MIB, master information block, from the PBCH symbol positions. That MIB will give you important detail about whether the cell is barred or not. Barred means it is not useful for you. You can't use this cell. If the cell is barred, it's conveyed as barred. Mobile will have to select another cell. This cell is not useful. You have to sync up with a new cell and do the same operation once again. Read the master information block from another cell, because this particular cell is conveyed to you in the MIB as barred, not operational. But any cell that you are, from which you read the MIB and found out that it is not barred, you will have to continue to read SIB1. SIB1 arrives on the PDSCH channel with, with perfect reservation, like SIRNT reservation. When it happens also is kind of pre-decided. It will happen, actually speaking, every 80 milliseconds once it will arrive, this SIB1. It's some kind of a fixed scheduling that works for SIB1. So mobile knows that every 80 milliseconds once it can listen to PDCCH to see which resource blocks are reserved against SIRNT, and download it, you will get your SIB1. So any mobile, if it wanted to download SIB1, will follow the same procedure. So they download and decode SIB1. In the SIB1, there is one important parameter called as PLMN ID. Stands for Public LAN Mobile Network ID, which is nothing but a network ID, which is equal to two details: mobile country code, mobile network code. Mobile country code for India is 404 and 405, one of the two. For some networks, it is 404, some networks, it is 405. For example, if you take Reliance Jio, it is 405. And mobile network code is again different for different states. In different PLMNs, different number will be there. For example, if you take Jio itself, and in Andhra Pradesh, it is 854 is the mobile network code. So in the SIB1 of the cell that mobile synced right now, if mobile finds this number 405 854, then mobile thinks that, okay, this is my cell that I have to latch on to. Because in the SIM card also the same number will be present. This PLMN number will be present in the SIM card. It will match this whatever the PLMN number that is present in the SIM card and the PLMN number that you are finding it in the SIB1. Both matches, that cell is operational. You can use that cell. This is how the selection will take place. For example, if you put a Reliance Jio SIM card in your mobile, why it is not selecting Airtel cell? Why it is correctly latching on Jio cell? Because in the Jio cell, this PLMN ID is available as part of system information. By reading it, you can decide. But any moment once mobile reads the SIB1, found out that PLMN ID is not matching with the PLMN ID. If it is not the PLMN ID that you have selected for your operation by the NAS layer, higher layer, if it is a no, then you go back, select some other cell, and again do the same operation. So you can use the cells only which are part of your PLMN, your operator network. You cannot use the cells which belongs to other operators, even though you can access them. You can read the SS block, even if belongs to other operators also. Your mobile can read the SS block at least, but it's useless. But once you kind of concluded that the PLMN is yes yours, you go to the next step. You look for SIB1 containing on-demand system information is enabled or not. You look for that in SIB1. SIB1 clearly telling you that on-demand system information is not enabled. No. Then definitely remaining SIB-related scheduling details will be provided to you in SIB1 itself. When SIB2 occurs, when SIB3 arrives, when SIB4 arrives, all those details will be available, clearly indicated. Using the details, mobile would be able to decode the other system information blocks. Easy. But if mobile found out that in the SIB1, on-demand indication is set to yes, now definitely this other SIB-related scheduling details, you can't find it in SIB1. It won't convey the details. It will tell, indirectly giving a hint to mobile that you have to request for it. You have to request for the other SIBs. which SIBs you want also, you have to decide that, which SIBs you want to download. You please decide and tell me, then I will send you that SIB scheduled on the PDSCH with reservation against SIRNTI. Even if it is not this mechanism, if they are regularly scheduled, even in that case also, the remaining SIBs will arrive on the PDSCH reservation with PRN, with the SIRNTI reservation basis. Definitely they will arrive here. But when they arrive, you will be kind of given a hint about it. If on demand is not enabled, but if on demand is enabled, you don't know when your PDSCH carry the SIBs, because only when you demand it, network will send you the data on the PDSCH. But how can you demand it? To demand anything, you definitely have to require preamble mechanism, because you have to send this SI indication, SI request in uplink direction to G node B. To send that, you definitely have to perform random access procedure. So you will get a lot of technical details that are required for performing a random access procedure as part of SIB1. By using those details, so mobile will trigger the preamble, mobile will get a random access response. As part of the message 3, mobile will send a SI request, which is nothing but on-demand scheduling information request, in which clearly mobile will say to the network, hey, I want SIB2, I want SIB3, I want SIB4, then I want SIB9, I want SIB10 and 11. So these SIBs I want. You clearly put an indication which and all SIBs you want. So mobile software is kind of capable enough to have this knowledge on its own, like which SIBs it requires to survive in this particular cell. So on the basis of it, it'll choose this, which SIBs it want. There are rules and regulations also to survive in a cell. How many SIBs are required, like in a mandatory way, in a mandatory as a mandatory case. So on the basis of that also, mobile would be requesting these system information blocks in the message 3. So in message 3, instead of sending RRC connection request or radio connection request, mobile is sending SI request. Hey, I am not even going to the step of radio connection. I am still in system information downloading, because you are not sending the system information at regular intervals, but sending it only on the demand. I am demanding now. Please reply back. So you get an acknowledgement in which you will get the scheduling details. So on the basis of the SIRNTA scheduling on the PDCCH, immediately the SIBs that are requested by you would be sent to you on the PDCCH channel. You download it and you use them for your operations, for your rest of the operations. So actually, a lot of SIBs are required for the mobile equipment to operate in the cell. So how the request will look like this way, this RRC system information request. So this is a RRC message that mobile equipment have to send to beg for the system information, in which it is having this requested SI list, which is basically a bit string of size 32 bits. This is 32 bits. Each bit can be set to 0 or 1. If the first bit is set to 0, you are requesting for SIB2. If the second bit is set to 1, you are requesting for SIB3. If the third bit is set to 1, you are requesting for SIB4. If fourth bit is set to 0, you are not requesting for SIB5. If your next bit is set to 1, you are requesting for SIB6. Like that, for every SIB, there will be one bit. If you set that bit to 1, you are demanding the network that you need those SIBs for your operation. You're demanding the network to send those SIBs to you. So how to read these RRC messages? I'll have to teach you. These RRC messages will be presented to you in the document in a language called as ASN.1. This will be taught to you later if you are participating in RRC protocol related activities by your team. So I'm not going to teach you the part of it. But I'll tell you one or two hints so that for the rest of the messages, you won't be confused. When you say sequence, colon is equal to sequence. So this is kind of a name of the message. And it is basically representing it's a record. It is a record of entries containing some information elements, IEs. So this IEs is a fashionable or technical word for parameter. Simply RRC parameter. We are calling it as IEs. But this is the 3GPP terminology. And these IEs, there can be many IEs. For example, in this particular sequence, you have a list of IEs, RRC system request IEs. Name of that is on the left-hand side, RRC system information request. A type of that will be on the right-hand side. The type can be a direct type, just like a bit string, octet string, like that, different data types would be there. Or it will have an indirect reference. In this particular case, it has got an indirect reference. This reference will lead us into the next part. So this is defined separately somewhere else. So you have to combine the things like that. So this message is not the end of it, because this part we have to see what is the definition of it. This definition also we have to see what is it. So each of the things which are not directly defined with basic data types, they will have indirect references. Like this, the one that you find here. Okay. Now from here you have come here. Now you found out that this is also a record. Sequence is a record containing two elements in it, two information elements in it. First information element is what are the SIs that you are requesting, which is a 32-bit bit string, which will tell you which SIs you are requesting. Whenever you see this color or double dash, you have to understand it as a comment. So that comment will tell you the information about it. It is not as part of the syntax. So this is commenting, just like in different languages. Like for example, in most of the programming languages, you will use two backslashes and write a comment in the programming. So this ASN.1 is also a programming language, but it's called as a data definition language. It's not a logical language like C++, which is used for defining the data. But what is the size of this information element? You will be known about it here. The 32-bit commenting there. That representing that it's comment. Now there is 12 bits spare. Wherever you see this word spare and whatever the size it may contain, that is kind of reserved for the future operations. So whenever you see spare, you have to ignore that. In any protocol, across the 3GPP, if you see spare, that's kind of dummy, always filled with zeros. Is useless. That's the meaning of it. Now, what is the positioning SIBs? This is normal system information. This is called as positioning system information, which are required when you are dealing with the positioning of the device, like locality to estimate the location of the device by using triangulation or various methods. Anyway, we are not going to study things related to it. Positioning things you won't be using, you won't be developing. So it is kind of waste. So even though you have the positioning SIB related IEC here, so that part we are ignoring. So two sets of IEs we have in our message. One set of IEs led to our normal system information. Other set of IEs led to positioning system information. But this we ignored. But there are other IEs called as positioning system informations as well, which will be, even if you demand positioning related information to the network will provide you that positioning related details, with which you will be able to estimate your own location. Even if, for example, your GPS is not available in a locality, you can still use this. Okay. Anytime you see any sequence with this kind of a notation, it is kind of considered as a blank sequence. The point is, it is reserved for the future part. In the future, they can have extensions. What is the meaning of extension? In the next release, if they decided to expand this message to contain many more parameters, they will put those more parameters in this extension future. They always have to keep it inside these extensions. They cannot directly add it here. The reason is backward compatibility always should work. The old mobile phones should not face the problem with the parameter. So you are not allowed to directly add the parameter there. You are allowed to add the parameter only under the extensions part. That is how it works. That is how the logic works. I will talk about these critical extensions more in the upcoming messages. There will be some good enough examples to understand that concept. I'll introduce that there. Okay, so this is RRC system information request that you send to request for what? Remaining SIBs. The one that you have to send by using your random access procedure. Now, what SIBs mobile requires? Mobile will get a lot of parameters here. Radio related parameters, NAS related parameters, positioning related parameters, it would be getting as part of system information to survive in this cell. But out of them, when the mobile is in idle mode or inactive mode, it must have MIB, SIB1 to SIB4, SIB5. If SIB5 is required if the mobile is supporting LTE network, SIB11 and 12, if 711 is required if the mobile is configured with our network is having idle and inactive measurements enabled. SIB12 and 13, 14 are required if the mobile is a NR SideLink mobile or a V2X device like car, vehicle to everything device it is. Then the device must read SIB13 and 14, which will convey vehicle related information or vehicle technology related information details. So it depends on which kind of a mobile it is. But minimum at least these many are required for every mobile, MIB, SIB1 to SIB5. Validity of the SIB is 3 hours. Every 3 hours once, whatever the system information that you already have downloaded, you have to throw into dustbin and you have to get the fresh system information once again, even if it is not changing. But if the network has reported you that the system information is changing, then you have to download it anyway without worrying about these 3 hours. If there is a paging message arrived reporting you that the system information is modified, you anyway will download it. But how does the mobile will verify whether you got the latest system information or not? Every time system information is modified, there is a parameter called as value tag that is present in SIB1. This value would be incremented by 1. Normally it starts with the value 0. It can go all the way up to 31 and again it becomes 0. Now, once operators have configured the system information, it is set to 0. As long as the operators are not making any modifications, the value 0 stays as it is. But if operators have modified the system information, automatically value tag would be updated to 1. Next, for the next 2 months, you did not modify the system information, again got modified, then it will become 2. Value tag will become 2. So every time any part of the system information is modified, value tag would be incremented by 1. It's a circular value. It will go all the way up to 31 and again becomes 0. That means already we reached 31. There, if any modification takes place, it becomes 0. The value tag number. This is known to every G-Node-Bs mobile, every 5G mobile. Okay. Now what we have to understand is, what are the important details that are part of master information block or the SIBs, etc.? What details mobile would get by downloading and decoding them? Is there any information that we gather there? Yeah, that is the part we have to understand now. So we are digging deep into these things. MIB, master information block. We don't need to study this. We already have covered this as part of the SS block. So we won't waste much of the time. For example, your DMRS type A symbol position, you will find SSB subcarrier offset, which we call as KSSB. You will find that. And what is the subcarrier spacing that is configured in this cell? Whether if it is FR1, it is between 15 and 20. If it is FR2, it is between 60 and 120. One of the value you find. System frame number. What is the running frame number? Every 10 milliseconds once, your frame number will be incrementing. What is the running frame number right now? It will be indicated as a value with 6 here. And whether the cell is barred or not. If it is conveyed as barred, you have to leave the cell and find out the next cell and deal with it. Now, intra-frequency reselection. If one higher priority cell is barred, then in the same frequencies, you are allowed to use other cells. If it is says allowed means you are allowed to use it, other not allowed means you are not allowed to use. So that means all the cells in that frequency range are barred. You have to select some other frequency. And there is a spare, which is 1 bit, which is kind of reserved for future. And this PDCCH config SIB1, when you are going to get SIB1 scheduling details, this part we have already learned. We get something called as core set 0 on this PDCCH config SIB1. On core set 0, you will be conveyed information about when you will get the PDCCH, which is conveying the scheduling details of SIB1, in which part, where do you get it, where is located. We have seen this in the physical layer as well. So we studied this in the physical layer, so we won't waste much of the time with the MIB. Now remaining SIBs we did not study. Now we start with SIB and we start looking into the deeper details here. Okay. Now the second thing that I have to explain. So this is a SIB1 information. Now, whenever you see this word optional, the meaning is the parameter is optional. That means when GNodeB is sending this SIB1, the parameter may be there, may not be there. It might be sending that parameter, it might not be sending the parameter. That is the meaning of it. It will be dependent on a lot of conditions. Those conditions are commented here as need R, need yes, need conditional, standalone case, need yes, like that. So all these things will have explanation in RRC. We will not have time to go through each and every condition, or in which cases these parameters are optional, in which cases these parameters are mandatory. All those things will not have that much time, because we have to study thousands of parameters as part of RRC. It's a huge subject. So we will quickly go through, and if you wanted to find out any deeper details, obviously you have to visit the spec and find out more details about each and every parameter. Complete description will be available there. Okay, first, SIB1 contains what details? Cell selection info. To select this cell, what is the criteria that mobile equipment have to follow? First of all, if mobile is getting some kind of signal strength on the, when it measured the SSB block, it got some signal value, some signal strength. How does mobile know whether that signal strength is good or bad? So those details are provided here. QRX level min. What is the minimum RX level that you have to receive in terms of quality? QRX level min offset, little offset value. Or QRX level minimum supplementary uplink in case of supplementary uplink scenarios. QQual min offset. So these are all some power level qualifiers, power level value qualifiers. All these things are. Mobile equipment will have to kind of substitute all these values that are being sent from the network into some mathematical equations. That mathematical equations will generate one output. On the basis of that output, mobile decides whether the cell is selectable or not. It is not straightforward. It is not like mobile will send, network will send one value, and if you achieve that value, you automatically be able to select the cell. It is not like that simple. So there are a lot of parameters. Not only these parameters, there are some additional parameters also will be there, which are already known to the mobile equipment without the network sending it. Those are called as fixed parameters, which are like kind of fixed in the mobile phone. The mobile phone knows them automatically. So there are some parameters which mobile knows. There are some parameter values that the network is sending. You kind of take everything into consideration and substitute them into equations. And based on the equation rules, you select that cell. For example, after substituting these values, you found out that you placed it into the mathematical equation. You found out that whatever the condition that it is that needed to satisfy, it is not satisfied. What does that mobile do? Mobile decides that this cell is not good for my operation. I leave this cell. So up to now, whatever the operation I did up to reading SIB1 is useless, because I found out that this cell is not in my operational conditions. How did I find? Based on the information network provided me. Network told me how much minimum signal strength you should get from this cell to access this cell or to use this cell. So what is that mathematical criteria? Where is that mathematical criteria which will help the mobile to do this cell selection? So those criteria are called as SRX lev should be greater than 0, S qual should be greater than 0. So these two values are greater than 0, then mobile will consider that that cell is up good for selection. Otherwise, if any one of these two elements are less than 0, then mobile should not consider that cell for cell selection. Of course, when you are finding that you found out 4 cells. In 2 cells, in one cell you found out SRX lev value is 8. In another cell you found out SRX lev value is 6. Both are greater than 0. Which cell you select? Obviously, with the bigger SRX lev value is better for you. That's the point. But to first of all consider a cell for your cell selection criteria, these parameters, these rules must satisfy. But what is this SRX level? How to compute it? That computational formula is here. What is SQL? How to compute it? The formula is here. What are going in here? It's a lot of parameters. Some parameters mobile would get on its own. Mobile would get from 0 to B. Some parameters mobile will compute on its own. It will calculate. For example, this QRX level measure is a measured value of received signal level strength, signal strength level measured by the mobile, minus QRX level min is a received value in the previous SIB1 information. Even this QRX level min offset is also received value. This P compensation also will be dependent on what is your mobile equipment, what is the maximum power it can transmit, and according to its power class, and what is the load power in this particular cell, P, called the uplink power value, called as PE max. So it is the differentiation between them. That term will go here as the P compensation. And there is this Q offset also that is sent to you in the SIB1. Ultimate point is, all these things are either decibels or dBms. The power values, all these things are. So mobile equipment will measure and find out certain things. Mobile will get a lot of parameters in the form of information from the network. What is the downlink power? What is the uplink power that you can use in this cell, etc., etc. Network will send you the details. Simply, mobile will substitute these things into this formula and find into these formulas and find both the values are greater than 0 or not. If greater than 0, the cell is good for selection, you use that cell. Otherwise, you should not use the cell. Is it clear, guys? I don't have time to go through each and every parameter. I'm not going into it. You have to find out when you wanted to study deeper, when you are implementing this particular thing. RRC is very big. Normally, RRC is to study RRC for generally, for example, for T-Cloud students, we teach RRC for about minimum to minimum 25 hours. But I was given 4 hours for completing RRC for your batch. So we kind of have to quickly complete it. So I will only be taking you through the bare minimum things that are needed for you to understand the concept. But if you need to go any deeper from there, you have to dig on your own. But I'm kind of giving you direction of what. So I'm not teaching you exactly each and every aspect in depth. Otherwise, I would have take you through all these parameters and explain. This itself would have taken 1 full hour. Okay. So that is cell selection information. On the basis of it, mobile would be able to choose whether the cell is good for your operation or not. Next, cell access related information. Now in this, mobile will find out the PLMN number, whether the cell is reserved for any other use. If it is set to true, then you cannot use the cell. The cell is not operational. Or if the cell is a public cell, you will find PLMN number. But if the cell is a private cell, it's called as a non-public network or standalone non-public network, then their numbers will be present. The private network numbers will be present. It's a private cell, which a private cell that is being brought up by somebody who purchased the private cell and deployed it in their house or deployed it in their office only their employees in that office can use that private cell. It is not a public cell where public can latch on to that cell and use use its services. Like that, these are private cells, or we call it as home GNODBs, or these kind of stuff. So if that is the case, then this will come into the play, NPN and SNPN. That time these details, but we are not going into it. So simply PLMN. Next. Let us go back. So the cell access related information, is the cell belongs to your network or not? Can you access this cell? Are you allowed to access this cell? That is what it will tell you. Next. Connection establishment failure control. If the connection establishment is failing, like till how many count you are allowed to keep trying for connection based on this value. For example, if it is set to N3, that's it. How many times you are allowed to attempt for the even if it is failing 3 times. If this fail offset is going to kind of give you this fail offset validity is kind of give you a time in radio frames. S120 is that many number of radio frames you can keep attempting for the reconnection even if it is failing. This is a time based factor, but these many times you can try in this much amount of time. That is how, when the connection establishment is failing for any reason. This is related to connection establishment once mobile attempts the connection. But this information is coming to the mobile as part of the network giving GAN. Network is providing the GAN to the mobile right now. Hey, if you are working in my network, what are the rules and regulations you have to follow? For example, if it is set to N1, you must attempt only one time. Even one time connection is failed, you have to consider it as a permanent failure and you have to leave this cell and select some other cell. You should not attempt the connection once again because the value is only set to 1. So network is kind of giving you what are the conditions to for you to continue in this cell or network. You should not like cast this thing. This is the point. Okay, next. This is SIB1. SIB1 contain remaining SIB related scheduling information. Okay, so what details are present here in the remaining system information? It will tell you which system informations are scheduled. So the scheduling info will tell you which system informations. Is it getting broadcasted or is it getting not broadcasted? If it is reported as broadcasted, you definitely will find out this window length and you will have this SIB mapping. This SIB mapping will tell you which SIB is going to arrive, okay, with what periodicity. What is the SI periodicity? For example, if it is set to RF16, every 16 radio frames once you will get this particular SIB, that is whatever the SIB that is mapped to this. I'm not explaining you the logical linking here. I'm explaining you what are the different details that can be present. Language point of view, how do you link this to this, etc. You will understand it later when you are learning ASN.1, when you are developing this RRC part. But I'm just telling you, mobile, for example, GNODB can schedule SIB type 5 every 32 radio frames once, or SIB system information block 7, 8, 9, it can schedule every 64 radio frames once. Like that, it will provide the scheduling details, which SIBs will arrive at what time, or how often they will arrive. So this continues up to all the SIBs. SIB 21, the latest SIB in release 17. If you attach positioning SIBs also, you will have positioning SIBs even some more. 9, 10, 24, 25, 4, 5, etc. So these are positioning SIBs. Even when they are scheduled, when they will arrive in your scheduling intervals, at what time. But if any SIB is conveyed as non-broadcasting also, if this SI request config is present, if this is optional actually, this SI request config is optional. But if it is present, this SI request config is present. The meaning is network is asking you, hey, I'm not broadcasting the system information. I'm asking you to send system information request. So that SI broadcast, the SI request config would look like this. So if mobile will have to send the SI request, in which RACH occasions it will have to send your preamble, and which preambles you are allowed to use out of the available 63 preambles, specifically, especially for SI related operations. So based on which preamble you are sending, network can detect you are sending the preamble for requesting system information, or you are sending the preamble to request for message tree transmission, like doing something else, like performing RRC connection or whatever. It will be able to detect because it is doing the splitting. It can segregate that some preambles and hint the mobile. Hey, only in these preambles you have to use one of the preamble to request for the system information. And how many times you want this SI to be like repeated? You can select that. So all these details are provided by the network, clearly indicating the mobile. Definitely you have to start random access procedure to send this SI request in the message tree format. But when you can send this SI request in exactly which RACH occasion, which RACH resource, by using which preambles. As simple as that. Other details you can find out, dig deep into it. So when this information is provided, then you will not have the scheduling information present for those SIBs. Instead, you will have that SI request related details. But this is optional. This may be there, may not be there. But if it is present, this will be set to this SI broadcast status would be set to broadcasting. That's how it works. Go back. So that is system information scheduling details of other SIBs. Now the most important thing, serving cell config common SIB. What is this serving cell config common SIB? There are two types of configurations that are possible in 5GNR. Serving cell config dedicated. This dedicated configuration related to the serving cell operations is provided to the mobile equipment when it is going into the connected state, when a radio connection is getting accepted. But as part of the system information, the general details, network is sending you these configuration details which are common for everybody, common for all the subscribers. Is not specific for any particular subscriber. Every subscriber will use the same common configuration, especially when they are operating in idle mode conditions, when they are not moved into dedicated state or connected state. In connected state, everybody would be given a dedicated configuration. So this serving cell config dedicated would be present in RRC setup message that is arriving from the G-Node when you have requested for a RRC setup. In that message, this dedicated package would be present. But right now we are having the common package. The common configuration details that you have to use in the lower layers when you are operating in this particular cell, those details would be there in it. So when I click on it, I go there. So it will contain downlink config common SIB, which will contain the downlink bandwidth parts and how much is the operational band, frequency band, etc., etc. Those details will be present in this downlink config SIB. Uplink config SIB will contain uplink bandwidth parts and related details. I did not expand them again. Again, these things will be expanded. This is a big package. This downlink config common SIB, for example, is a big package. Contains a lot of details in it related to downlink configuration. This is related to uplink configuration. This is related to uplink, supplementary uplink related configuration. If supplementary uplink is configured. N timing advance offset. This we already know. We already participated in this and in the test also. NTA offset. NTA offset is common for every subscriber. You are getting that value. N0 or N2 25,600 or N39,936. On top of it, you have NTA, the timing advance that we'll have. And there are more details here in this serving cell config common related to SSB periodicity in the serving cell. And what is the amount of power the network is using to transmit this SSPBCH block? What power it is using? Of course, this is sent to you in the integer format. But what these power values always be sent in the integer format. But what is the relationship between this integer and the DBM? That will be that information will be provided in the RRC specification. So for every parameter, power related parameter, always you will get an integer value, but that won't be directly representing DBM. So there will be some kind of a relationship formula that will be present in the RRC spec. So when you go to this particular RRC spec, you will be able to find out what is the relationship between the integer value you are getting and the actual DBM value that it is using for transmitting the SS block. Access modes and all that I did not explain you. And this high-speed configuration is whether this cell is a high-speed cell or not. If it is a high-speed cell, it will contain high-speed related configuration details, and so on. So general cell-related details, like what, for example, from this parameter, mobile equipment already can guess one thing. Actually, mobile is already, this is SIB1 that we are studying. By the time mobile read the SIB1, already mobile completed the PBCH reading as part of the SS block, because it is all after SS block. After reading the MIB, you will be reading the SIB1. It is not the other way around. Now you already read the MIB, or you already got the PBCH channel or SS block. Now mobile must have already found out what is the power on the SS block it has received. Now it is getting an indication from the network that with how much power actually network is transmitting the SS block. Based on it, you kind of can estimate how much power network is using to transmit, how much power I am getting. You can kind of come to some kind of an understanding about what's going on in the network, what your radio conditions. Next, UE timers and constants. There are a lot of timers, T300, T301, T310, T311, N310, N311, N319. Again, if you remember this year, T311, we have seen that timer already as part of default configuration. If provided here, it will override the previous value, that the default value that's known to every G-Node-Bs mobile. If not provided here, it will be, the default value would be used. But each of these timers would be used in different operations. Let me tell you one, T300. T300, if it is set to 100 milliseconds, what is the meaning of it? Mobile would start a procedure called as RRC setup request towards the G-Node-B. After sending this message out, mobile starts one timer. That timer is T300. Now, before you receive a reply from the network, this timer should not be expired. 100 milliseconds should not be expired. That means that we are expecting a response from the network within 100 milliseconds. If not happened within 100 milliseconds, you will consider that this RRC setup procedure is a failure. And you have to take the next step based on the conditions again provided in the RRC specification. RRC specification tells you If the setup is a failure for the first time, what you should do, what value you have to observe next, and then what should be your next step. Clear cut instructions would be there in the spec. Based on that, your mobile would choose the next step if the timer is expired without receiving a reply from the network. So this will be configured to 100 milliseconds, 200, up to 2000 milliseconds, which is approximately equal to 2 seconds. This would be configured dependent on the GNodeB is normally dealing with how many subscribers in the network. If it is a huge subscriber base in that particular location, you have to configure a bigger value. Operators will configure a bigger value because a lot of subscribers may be requesting for the radio connection. It may take time for the GNodeB to respond to everybody. So it takes more, if it requires more time. But if GNodeB is a very small cell, which is very covering very small area and covering very small data subscriber base, now obviously the GNodeB is capable enough to respond back with 100 or 200 milliseconds itself. So on the basis of GNodeB's capacity, GNodeB's hardware and software capabilities and various other things, they would be configuring this value. For different GNodeBs in different places, different values will be configured. So this all works on the basis of operator settings. Operator, when they are bringing up the GNodeB, they will do these settings. And when mobile equipment is started reading system information, so mobile would get these values as part of this system information. Hey, these are the timers that you have to follow in this network. For example, if value given is 400 milliseconds, network is indirectly telling the mobile that I'm a medium range, medium responding device. I would take a medium amount of time, 400 milliseconds, to respond back to your RRC request, RRC setup request. You should not expect it earlier, but you must receive it, my response from 400, within 400 milli. If not received, you kind of consider that something bad happened and you have to do whatever you're supposed to do according to the RRC spec. Like that. Every timer and every constant will go into a procedure. And I don't have time again to explain you what is these timers and constants and which timers and constants are used in which places. But I will do one thing. I'll show you where these are located. And if you wanted to find how to find it and understand their descriptions, this is the RRC spec. Spec number is 38331, release 17. In this, you have section 6 and above, where you will have these details present. Now, these details that we are looking for right now is here in the variables and constant section. Typically, you have these timers. So if you take a look at the timers, T300, when do you have to start the timer? When the timer should be stopped. If the timer is expired in the middle of the procedure, what you have to do? Perform the actions that are mentioned in this particular, in this section 5337. There are some steps that are mentioned. Mobile, you have to write the software, mobile phone software, to work the way that is explained in this section. That's the point. So for every timer, like you have a when to start it, when to stop the timer. But if the timer is expired without a particular job done correctly, then what you are supposed to do? So a lot of timers would be there, and every timer related explanation will be available here. And when you are developing this RRC protocols software, you will be looking at what is the procedure that you are developing and what are the related timers for that, and implementing those timers and the related logic in your software. That's what you have to do. These many timers we have. And there are counters. There are constants, there will be counters also. Two constants, N310 and N311, related to mostly out of sync and in sync situations. For example, N310, if you see, maximum number of consecutive out of sync indications for the SP cell received from the lower layers. That's a constant value. If you cross that value continuously, if you are in out of sync, the lower layer is reporting, which is nothing but MAC layer is reporting to RRC. RRC will consider itself as radio link failure. If out of sync is received too many times, more than crossing this particular N310 value. So N310 is set to what? N310 is set to, for example, N6. That means already 6 times lower layer has told you that we are out of sync. That means your radio link is failure. You have to execute radio link failure related situation. There is another timer, N311. It can also be set to N6, the same value. It is lower layer is reporting you are in sync continuously. Then you will come out of that radio link failure situation and come into in sync state. So this is related to out of sync and in sync, timing advance, uplink timing advance related elements. These two are N310 and N311. It would be used on those timing advance related formulas, timing advance related operations. Like that. So that is UE timers and constants. Next. Something called as USC, which I'm going to ignore. USC stands for Unified Access Control, where operators are allowed to configure some special user identities or user access classes for different subscribers. And on the basis of it, they can prioritize the subscribers. For example, emergency subscribers, machine critical network subscribers, or you can say multimedia prioritization subscribers, or maybe like prime ministers, chief ministers, VVIPs, and they'll have separate codes allocated, unified access control codes allocated. Now, when you are trying to connect, get a radio connection, you kind of quote what is your present UAC code, use unified access control code. Now, if your mobile sends that unified access control code, if you are suggesting that you are a high priority subscriber, network will give you, like more priority. If you are fighting with others for the resources or radio connection in a congestion situation, you will be given priority. If you are making emergency calls, or if you are a special subscriber having this unified access control class allocated to you because you are a VIP or a VVIP or whatever. So that mechanism is this whole thing. But we are going to ignore this because this is going to take a lot of time to study. If required, if you guys tell me that this is needed, I'll send you the specs related to it. You can go through it. But we normally teach it for our students, but for you, we don't have time. So we are leaving this part empty. But this information is related to it. UAC related things. Unified access control related information. Okay. Next. Now take a look at this. Every protocol message, you have a non-critical extensions which is set to either a blank sequence or set to next level IE. For example, this SIB1 is developing release 15. Release 15, they only thought about these many parameters. But release 16, new information is coming up. So whenever any new information is coming up, new parameters are coming up, they will always keep it as part of critical extension. So now the critical extensions is pointing to SIB1 release 16 IEs. When you go there, you will have in SIB1 what are the new parameters that are newly introduced, and the related configuration details will be there. Again, I'm going to ignore most of it. I'll tell you one here, one there, just to cover the part. For example, in release 16, they have decided to have idle mode measurements for UTRA and NR. So they are getting enabled or not. So that choosing mechanism is here. True is set means it is chosen. Now, version 16.10 represents release 16 subversion 1 in that. So basically it is 16.1. The 16.1, 3 parameters are introduced. But in 16.3, again additional parameters are coming up. So this will lead to 16.3. So what are the additional parameters that came up? Some UAC related parameter came up in 16.3 version, release 16.3. But again, non-critical extensions is not set to blank sequence. It is set to version 17 IEs, 1700 IEs, which is release 17 IEs. So in 17, there are some more parameters that they have introduced. These many more parameters they have introduced. For example, related to some new UE constants, timers and constants, and some configuration related to, for example, REDCap UEs stands for reduction capability UEs, or some kind of IoT devices are considered as reduced capability devices. For them, the special configuration details will be provided, and a lot of additional USC related information. And there is a new technique that is brought into play called as SDT, small data transfers. It is called as, which normally we use in inactive state. So small data related configurations, small data transfer related configurations. So all these things are brought up in release 17, and the corresponding configuration parameters are here. So every release will have a link to the next release. For example, if you are developing a release 16 mobile phone, let us suppose, and you are stopping at release 16.1. Now, in your mobile phone RRC protocol software, the message will end here. The message will end here. This won't be leading to IEs. Instead, you will have a blank sequence, just like this, blank sequence. For example, in release 17 IEs, non-critical extensions is containing a blank sequence. So if you are developing a release 17 mobile software, so this will be a blank sequence. But tomorrow, if release 18 is coming up, maybe after 1 month, 1 year, in the release 18, they have decided to add some more new parameters in SIB1. So then instead of this called as sequence, blank sequence, in that place, you will have SIB1 V1800 IEs. You will have. In that, you will have V1800 related package would be present, and that will contain some parameters, some IEs and their values that you can set related to the new features that they are implementing in release 18. Because every release will implement new features. If features are increasing, parameters will increase. Parameters will be there related to that features. That is how you have to understand this. So in a release 15 mobile, you don't have these features. In a release 15 mobile, you don't have these features. Release 15 mobile, you don't have these features. If you take release 16 mobile may have these two features, because release 16.1, release 16.3. But these features won't be there in release 16 mobile. These parameters won't be there. It cannot understand. Even if the network is advertising these parameters, mobile will ignore it. Because mobile is a release 16 mobile, but network is release 17 network. Normally network will be advanced. Network always they will be upgrading the software. Mobile you will purchase every 3 years once. When you purchase release 15 mobile. Next year, release 16, release 17, network side is getting improved. But that doesn't mean that mobile side also there will be improvement. Need not be. So mobile work with only release 15 related logic. That's it. Only it can support release 15 features. So network, when mobile clearly tells that it is a release 15 mobile as part of the capability information, network never does any feature configuration related to release 17 for the subscriber. It will tell that I know that you are a release 15 mobile. I will configure everything within your bounds, within your release 15 bounds. That's what network does to the mobile. So that is how you have to understand these non-critical extensions always. So any protocol message will have non-critical extensions in RRC, but if that is a blank sequence, in the next releases, they did not introduce any new things. That is the end of it. But if it is containing one name here, you have to lead to that name, find out where it is and what is the extra information that they are bringing as part of that release. But that doesn't end there. Version 1610 means it won't end at 1610. 1610 again contain non-critical extension, which should be blank. Only when it is blank, it ends there. If it is not blank, if it is containing 1630 or 1670 or 1700 or 1750, so you have additional things that are getting introduced. So SIB1 will carry the most crucial details that you require for your operations. Of course, I did not expand the cells serving cell config common. If you go back once again there, you see what details are present here. Downlink config common SIB, uplink config common SIB. As part of this downlink config common SIB, not only you will have information related to um, bandwidth parts, etc. You will have information related to, for example, in uplink config especially, you will have details like how you have to use your RAT channel and so on. A lot of details would be present in it, in that there. If you remember how many preambles you can use, etc., etc., a lot of details. All that would be part of it. But I did not show you because we already have studied it, a lot of it already in physical layer and MAC layer. Simply you have to understand those parameters would be present in it. So SIB1 carries all the crucial details that are required for the mobile equipment to do random access procedure. Needed details. Okay, next. That takes us to SIB2. Okay, from here onwards, we'll not take much time. We'll quickly move forward by studying each one in 1 minute time. We put a timer set. SIB2 contains cells selection and reselection parameters that are required, that are common for all the types of cells that are present in the adjacency, like interfrequency cells, intrafrequency cells, and inter-rad cells. What are these different types of cells? Intrafrequency means same frequency cells. For example, if you are operating on one particular frequency, which we name as F1 in a cell, if adjacent cell also is operating on F1, we call it as intrafrequency cell. But if you have one cell which is operating on a different frequency, but is a 5G cell, NR cell, we call it as interfrequency cell, inter. So the frequency is different, it is inter. If the frequency is the same in the adjacent cell, it is intra. But if it belongs to a different technology altogether, radio access technology, RAT stands for, then it is inter-RAT. For example, here we are operating a 4G cell in the adjacency, so LTE cell. So that would be considered as an inter-RAT cell. So to select the cells which are present in the adjacency, which belongs to same frequency of present NR cell, or different frequency but NR cells, LTE cells, GSM cells, UMTS cells, etc., different radio access technology cells, what are the different cell selection criteria for them, especially the common criteria applicable for everybody. That details will be provided. So if you have to select any one of those cells, what should be your cell selection criteria? What are the power values that you have to consider them for the mathematical formulas? But these are the common parameters that are applicable for everybody, everything, all these different types of cells. So again, this SIB2 contains your power related values. Your QRX level, min, yes, P max, which is uplink power value, etc. RSSI, received signal strength indicator in the SS block. So how many SSBs you have to measure to find out the signal strength. So what is the SSB index number that you get, that you derive the SSB block index number from the cell or not, and so on. A lot of details will be sent to you. You use these parameters in your in selecting of the cells. And first of all, whether this particular cell is a high-speed cell or a medium speed cell, if what range of the cell value is better considered as the best cell for you. Threshold means wherever this word threshold is used, you have to consider that that is one boundary value. If you cross that, you are supposed to do something. Or if you go below that, you have to do something. So there are some threshold values always will be provided. So above that threshold value, your action would be different. Below threshold value, your action would be different in different radio conditions, different situations. So mobile will measure, compares it with these threshold values to take up the next step, to decide what to do within the next step. Okay. This is SIB2 containing lot of radio signal strength related parameters that will help the mobile equipment to select the adjacent cells when present cell is not looking good. By using these parameters, the cell will be able to make a decision. Now SIB3. SIB3 contains information related to what are the actual cells that are located, intra-frequency neighboring cells that are present, what are configured. First of all, how GNODB knows for a cell how many cells are configured. When operator bring up the network, operator will store these important details into the software configuration. Hey, for the present cell, these are the adjacent cells that we have, the neighboring cells. We have totally 3 cells are there, or 4 cells present in this locality for the as a neighbors. And you have to convey that information to the mobile. Hey, you right now you are accessing one cell, but for this cell, these are the adjacent cells, and their parameters and their details would be sent here. For example, their physical cell ID would be sent, PCI, the scrambling code. So if you go into that intra-frequency neighboring cell list, what is the physical cell ID and what is the exact power offset values that are applicable for that cell selection, that neighboring cell selection. These offset values are typically added or deleted from the previous common values that are already received in SIB2. So it is SIB2 plus these. It is like that. For every, all common parameters will be in SIB2. Modifications will be suggested separately for each cell. But each cell would have different power values. Different power values are considered as sustainable for that particular cell. It's like that. Intra-frequency excluded cell list, the cells that you should not use, even though if you find them, you should not use them. Like blacklisted cells there. What are the range of those cells? Are intra-frequency CAG cells. CAG represent closed access group. For example, you can purchase one private GNODB for 20,000 rupees from the operator and you can install it at your home. Now you will be given a family ID called as a CAG ID. So there will be, you can attach a family name also to it for this CAG cell, closed access group. Now, this is this cell. Are there any private cells that are located nearby? And if they are, what is the CAG list of CAG IDs that are located? And if you are a subscriber who are part of that CAGs or one of those CAGs, you can decide to select those cells and see if the signal strength is good. If good, you will latch onto them. For example, you went to office, you came back home. The moment you comes back home, you will be taken out of the public network and you will be put onto your CAG cell, your closed access group cell. So obviously your data rates will be more because it's a dedicated cell only for you and your family members. For example, it's a private cell. So are there any such cells? If they are available, what are their IDs? So it's network is kind of giving GAN to the mobile equipment about, I know that you are here in this cell, but you also need to know your surroundings. How many cells are present in the adjacency? What are their IDs? What are the physical cell IDs? Because you require scrambling code to do any operation, even with the adjacent cells. So it is provided in the form of scrambling code, N cell ID we called it as. We studied that many times. As part of your scrambling also we use this. So that is kind of unique for every adjacent cell. The physical cell ID or the scrambling code that will be provided. Now this is intra-frequency cells. This is arriving to the mobile in SIB3. So what does SIB4 contain? Intra-frequency cells, SIB4 contain. Same information, but different frequency. NR cells only, different frequency cells. Not the same frequency cells. Different frequency cells that are adjacent to your present operating cell, where you are downloading this system information. In relative to that, they are adjacent. Okay, next. I'm not going into the details of that thing. Information is same, even if it is interfrequency. So you have details like what is Q call, min, all these details will be there, RSSI measurements and SSB block details, which SSB to measure or not, and all your power related measurements only. A lot of parameters would be there related to power measurements. All that would come in. Next. SIB5 contains only LTE related cells and their informations. What are the LTE neighboring cells that are located, and what are their carrier frequency, and what are the scrambling codes that are applicable for the LTE cells. So this ARFCN will give you the LTE cell frequency and what are the power levels that are good for, considered to be good for LTE cell. If you find out 5G cell is not good, then you have to select 4G cell or LTE cell for your operation. Then how do you know even the adjacent LTE cell is good for you or not? So required power levels. Again, even you mobile will have to substitute these power values into mathematical equations that are provided by measuring the signal strength, and then it will find out whether the cell is good or bad or whatever. So all these parameters up to SIB5 are kind of providing the cell selection and reselection criteria for the mobile to survive in idle mode. Only thing mobile would be doing in idle mode is selecting which cell is good for its operations. Present cell is good or adjacent cell is good. Adjacent cell, which adjacent cell is good. But all these decisions must be based on the network provided advice. So network is providing the advice. If you find that this cell is within this signal strength range, this cell can be considered as good for you. So you can use this cell services. You can latch on that cell if you want. If you find that the present cell is not good. So this is all the advice. This is only applicable when the mobile is in idle mode or connected mode. These cell selection, reselection parameters are applicable. If the mobile is in connected mode, which cells to measure, network will control that separately. That mechanism we have to study when mobile equipment is in connected state. Now we have SIB6, System Information Block 6, contains ETWS primary notification. What is this ETWS? Stands for Earthquake Tsunami Warning System. So if government wanted to advertise any of the emergency messages, for example, one satellite system picked up that there is a possibility of a tsunami in a particular area. Now you have to alert the people there. Hey, in the next 5 minutes, you are going to get a tsunami. Please escape from here as early as you can. So it's a public warning system, this ETWS is. Mobile don't require to download it, download this message normally. Normally, this SIB6 won't even be distributed. It will be empty most of the times because continuously there won't be any warning messages for the public. This is a very rare phenomenon. Maybe once in a year in a particular area, this might happen. But when it is there, it's going to kind of contain a message ID to recognize that message separately from the previously received messages, serial number, what kind of warning it is. Is it a earthquake or is it a tsunami? Is it some kind of a cyclone or what kind of natural calamity or human-made calamity related emergency this is, etc. Those details would be sent first. First, a warning message will come. This is called the primary warning. Your phone will start ringing and vibrating without stopping, just to tell you that there is a warning. But this is a primary notification which comes in SIB 6. Then mobile will have to download SIB 7 also, which will carry ETWS secondary notification, which will contain proper details like warning message. The big warning message will be divided into segments, and in which language it is sent. Based on it, the data coding scheme will be set, like in English or Hindi or Telugu, whatever the language that is sent. Based on it, mobile will decode it and display it to the human beings. Hey, this is what is the estimation. These are the instructions. These are the phone numbers you have to call in case of emergency. So these are the rescue teams if you are already struck up in the calamity, etc., etc. A lot of details can be sent in the form of small message segments. All of it would be combined and will be shown as a big message to the subscriber. So when government wanted to use these public warning systems, they would be asking the operators to distribute this information on these ETWS, SIBs, SIB 6 and SIB 7, also SIB 8. SIB 8 is also for emergencies. This is called as commercial mobile alert service. It can be used by commercial organizations also for alert. Like, for example, a big factory or a company can implement the CMAS for their particular subscribers and send them emergency messages only within within the locality of their factory, for example. They can implement it if they want. But ultimately, this is also a warning system, this SIB 8 also. So SIB 6, 7, and 8 all warnings, public system warnings, required to be downloaded by the mobile only when the information is present in them, otherwise not required. But how does mobile know? Normally, mobile won't download them at the starting, but network will indicate the mobile that, hey, you are supposed to download SIB 6, 7, and 8 now, that there is data arriving in that. How does network will tell the mobile? Paging, we already have seen that earlier. Paging message with something called as a short message indicating about ETWS. I have showed you that already earlier. So that indication will, once mobile gets that paging message, on the basis of it, mobile decides. ETWS CMAS indication in DCI format 10 in the form of short message code, second bit is set to 1 in the short message value. If that is set to 1, there is ETWS primary or secondary or CMAS notification. So you're supposed to download SIB 6, 7, and 8 if the second bit is set to 1. If the first bit is set to 1, other system informations have been changed, like SIB 2, 3, 4 might have been changed, but not SIB 6, 7, and 8. 6, 7, and 8 are specifically emergency messages. When they are changed, second bit would be set to 1 in the short message value in DCI format, 10. From that, mobile will get the understanding. Mobile will go and download the SIB 6, 7, and 8 wherever they are scheduled. SIB 9 contains general network-related timing information. For example, daylight saving time, or what is the local time in UTC. Like, for example, how does your mobile equipment automatically catch up the time when it is switched on? You're switching off for 10 hours. When it is switching off, it is not maintaining the time. Maybe when you switch on, it automatically gets the time. So network provides that information. Of course, devices are capable enough to maintain the time locally also. But for that, you need to maintain a small battery which will be kept on running the timer related hardware in the background. So then you can still maintain the time even if the network is not available. But typically, network will provide you the perfect time. Leap seconds, advanced leap seconds, if at all you have to apply in case of leap years, and so on. So these are timing related data, which is again not required for the mobile equipment's general radio related operations. These are required for non-technical purposes, by human related purposes. This information is needed. So SIB 6, 7, 8, and 9 all are general data, not technical telecom technical details. SIB 10 contains human readable network name in case of NPNs, non-public networks. What is the network name? The name will be present in SIB 10. But if you are not a non-public network subscriber or a mobile device, you don't need to even to read it. You can ignore it. SIB 10 is not needed. SIB 11 contains information related to idle and inactive measurements. What are the things that you have to measure when you are in idle mode or inactive mode? The details will be present in SIB 11. And mobile will have to measure the things in idle or inactive mode, but the measured details need to be sent to the network after coming into the connected state. That is how it works. But this is going to contain big package. I have decided to ignore, like the details related to it. If you want, you can go and search for this. You will be able to find in the spec, and it will tell you what are the exact idle and inactive mode measurements that mobile is asked to by the network to start measuring and logging them. And there are a lot of SIBs. I have not even decided to show you any further sub details, and I wanted to show you all at once in one place. So that too only from 12 to 21 are used for NR sidelink or V2X related operations, or satellite assistance information, or multicasting broadcasting, or multimedia service related broadcasting, MBMS related services. So for all different tasks, we'll use different SIBs. So if mobile is interested to do those activities, or if the mobile device is that kind of a device, mobile would read these SIBs. Otherwise, mobile don't need to read these SIBs. So the crucial SIBs obviously are going to be from SIB 1 up to SIB 5 are the crucial ones. SIB 6 onwards are general, and the other SIBs also are required only when your device is a particular special device doing particular things like multimedia broadcasting, downloading, or V2X related activities, or slice specific related activities, or things like that. Disaster roaming, when you are making emergency calls in a roaming situations in a disaster environment, and so on. All right. Okay, now whatever the information I showed you, system information, that would be sent to every single mobile when it is first time when they are when they are coming up in the cell and synchronizing with the cell, either in a scheduled fashion or a repeated time intervals, that information would be sent to the subscriber. But if a mobile equipment wanted to go into the connected state and wanted to get the dedicated configuration details, then it must use RRC connection control. Now, different procedures will be there here in connection control. The first procedure is paging. We already have seen a little bit of paging already. Paging is a unidirectional procedure which network will be advertising paging messages to the mobile by using PRNTI. We already studied that. So for a mobile which is in RRC idle mode or inactive mode, to advise the mobile equipment to do something, network will be sending you this paging message. What details will be there present in the paging message? You will have something called as paging records. There can be multiple records, n number of records. One record corresponds to one mobile. And in each record, there will be one separate ID would be present. The ID belongs to one particular subscriber. For example, it could be this. So you have a paging message received. It is telling you how many records are present in it, record list. So there can be n number of 1 to these many number of records you can have. Each paging record is going to contain what is the UE identity, which UE is getting this paging message. And that UE identity also, the paging UE identity also can be either core network provided ID called as STMC, temporary mobile subscriber identity allocated by AMF, either that, or if the mobile is in inactive state, your radio network is sending the paging with IRNTI. This is IRNTI is nothing but inactive RNTI. So by using one of the two, network is sending you a paging message asking you that, hey, you are getting something in the downlink, please come into the connected state, leave this idle state or inactive state immediately. Network is advising you that. And sometimes in release 17 they also have this additional parameter to identify if the paging is actually triggering a voice call or not, incoming voice call or not. So that is specifically added in release 17. Up to release 17, this is not there. Only you know that network is sending you paging up to release 16. But in release 17, if the paging message is related to a voice call, network will tell you exclusively that fact. Hey, this paging is related to a voice call, so you have to take it immediately. You have to decide what to do, and you have to respond back. There's a kind of a hint to the mobile to act fast, especially in case if it is a voice call. This non-3GPP part you can ignore, access type. We did not study anything related to non-3GPP, not part of our curriculum. That itself will be separately 10-15 classes we have to cover for non-3GPP, if at all we study that. But we are not learning it. So we can ignore any time non-3GPP specific things are mentioned. Okay, paging message will tell you if you are getting something incoming, if at all arriving, then ask you to come to the connected state from either idle state or from the inactive state. That is the paging procedure, happening only unidirectional. Of course, once mobile receives the paging message, he will start some other procedure on its own. But that procedure won't be considered as a continuation of this procedure. If mobile receives a paging message to come into the connected state, mobile will start RRC connection request, RRC setup procedure. But that is not considered as part of this procedure. This is considered as a single step procedure where it is receiving just a paging message from mobile is receiving a paging message from the network. That's it. Okay. So what is the procedure mobile starts when it need to connect to the network? RRC connection establishment procedure. So this RRC connection establishment is required for establishing SRB1. Right now, mobile equipment have got only SRB0 configuration active, but to activate SRB1, it need to send a request to the network. And also, as part of this procedure, at least at the ending, mobile is given a permission to send the first NAS message to the core network, AMF, non-access signaling message, which is higher layer to RRC. So you can send some kind of a service request to the core network as part of this procedure itself, but not at the starting. During its finishing, you are allowed to do that. You are allowed to send the NAS message. But network, when a RRC connection is requested by the mobile, may not always accept it. It may reject it, especially when it is facing load situations. Then network may reject the service. Tell that, hey, I cannot accept radio connection that you have sent me, so I'm rejecting it. And also, network will tell you for how much time you should not re-attempt. Even the timer also will be provided. So obviously, the procedure, RRC connection establishment procedure, is kind of two different things: a successful scenario, a failure scenario, when especially network is rejecting it. So what happens in a successful scenario? What happens in a failure case? But in both cases, The message mobile sends is the same. RRC setup request is what is sent to the network. But network may come back with RRC setup, which is a positive acceptance or successful operation, part of successful operation, or network can come back with RRC reject. So either one of these two messages happen from the network, depending on what network is facing right now. But if it is a positive reply, the procedure will continue. Mobile, by taking that configuration provided by the network, it will configure itself and it will kind of send a setup complete, a third message as part of this successful procedure. In this setup complete message, it will also include this NAS message. It will pack the NAS message in it and give it to GNodeB. GNodeB will have to forward that NAS message towards AMF, in which service related request will be there. Normally, you create a radio connection only for the purpose of communicating with the AMF. So once the radio connection is accepted and it is created, you wanted to, mobile definitely wanted to speak to AMF about it for service related aspects. So it definitely prepares a NAS message and packs it into this RRC and send it to GNodeB. Mobile knows that GNodeB removes it and pack it into NGAP protocol and send it towards the NAS component, which is nothing but AMF and SMF. On the face of it, this setup complete message is a kind of a thank you message. A thank you for accepting my connection. That is it. On the face of it. But it is also carrying NAS message. So this is, you can consider it as RRC plus NAS. This time only we call it as NAS being piggybacked. NAS message is piggybacked on top of RRC. So GNodeB reads the RRC part of the message and it does the job that it is supposed to do when it receives a RRC message. But it will extract the NAS part of it and it will start forwarding the NAS part of it towards AMF. Two things it will do, because you are receiving both the things together as a package, RRC plus NAS, you are receiving it. But here is one more important detail. This RRC connection setup is done on CCCH, Common Control Channel, by using SRB0. Of course, transmitted on top of uplink SCH by using the radio resources acquired through random access procedure. So this is what we call as message 3. But we definitely use CCCH because it's before RRC connection. Even this RRC setup also happens on SRB0, CCCH, but it is happening in downlink direction. Transport block is called as downlink SCH. And this is going to come to you as part of message 4. Along with your CRI, you will receive that RRC setup. But in this RRC setup, you will have all the required configuration details for your own dedicated configuration of the subscriber. So definitely mobile equipment, when it is sending RRC setup complete, it would be sending this setup complete message on SRB1. And DCCH, dedicated control channel 1, it will use to pack it into uplink SCH and send it by using the resources that are reserved in your DCI information against your temporary CRNTA. You will send that RRC connection, RRC setup complete on SRB1, because network already told you that it is accepting the connection. So you're allowed to use SRB1 now. You don't need to use SRB0 anymore. SRB0 would be used only one time in sending, one time in receiving. Remember, the meaning of SRB0 or SRB1 is always referring to what is the lower layer configuration you are allowed to use. That is the meaning of SRB0 or SRB1. The moment I say SRB0, you have to know, should not use PDCP, RLC should be operating in AM mode, MAC layer should multiplex CCCH onto uplink SCH, or from downlink SCH, it will extract CCCH with logical channel ID number 0, and the scheduling will happen on the corresponding, the ongoing RNTIs like RE RNTA, temporary CRNTA. So that is the lower layer configuration that you have to operate with when I'm talking about SRB0. When I talk about SRB1, PDCP is configured this time. So you may be performing encryption, decryption, ciphering, etc. Those kind of things you can perform now. Of course, for that you have to activate it. But that kind of things can be done. Here there is no chance because PDCP itself is not there in SRB0 configuration, as you are using it before RRC connection. So we have to see the details one by one. So in this setup request or in this setup request, what details would be present? Either in case success case, reject negative case, request would be same. RRC setup request contains RRC setup request IEs. RRC setup request IEs is expanded here as a record containing UE identity. The UE identity can be either core network provide identity, STMC part of the STMC, or if you are already not registered with the core network, you are allowed to send random value. Random value is any random number, which is basically a 39-bit random number. Any number you can send. Just randomly you select one number and you send it. If you don't have a STMC allocated by the network. For example, if this mobile is already registered with the core network, definitely mobile would have the STMC available. Mobile definitely will use part of the STMC only to inform itself or to let the network recognize it. It will be using that ID quoted by the network or provided by the network. But if you coming up for the first time, this is the first time you purchased a SIM card, put it into your mobile phone and switching it on, you never registered with the core network earlier. So definitely in that time, you don't have a choice but to use the random value. So mobile is allowed to just pick one random number and send it as its ID. And second detail after the UEID is establishment cause. For what purpose you are requesting for the radio connection, RRC connection? What purpose? You will quote different reasons. Hey, I want to make an emergency call for that purpose. Emergency voice call. Like, for example, you're making a call to 108 ambulance or police station, whatever. Those are called as emergency calls. Or are you asking radio connection for high priority access if you are a high priority subscriber? Either MPS priority access or MCS priority access. Stands for MPS stands for multimedia priority service. MCS stands for mission critical service. Related subscribers can request for special priority access. Or prime ministers, chief ministers are, like if you pay 1 lakh rupees for your SIM card per month, those guys can have the higher priority chosen according to their access class. Or you are making the established call establishment for the purpose of MO signaling. That means if you wanted to speak to core network, that's why you are making the radio connection. Or you wanted to generate the use, you are generating user traffic, your user data. That is why IP packets you have generated. That is why you are requesting for the connection. Or you are generating a voice call, or you are generating a video call, or you are generating a SMS message. So for what reason you are requesting, or you got any paging message for which you are responding? This MT access stands for mobile terminated. T stands for terminated, which is the typical word that we use for incoming calls. Terminated. Terminated means not call cutting. It is incoming call, basically. Mobile originated, mobile terminated. Mobile originated is outgoing call, mobile terminated is incoming. So if you receive a paging message, that's why you are responding back to the paging message by sending the RRC kind of setup request. So you're telling the network that you only send me the paging message. I would like to respond back to that paging message with the core network or AMF. That is why I'm requesting for, radio connection. Please give me radio connection. And there are several spare values for future purpose. Right now, there are no use. One of the reasons mobile will choose for exactly what reason you are requesting that radio connection. For example, if one emergency subscriber is requesting for the call and one normal subscriber, now resources are available only for one. Definitely, the emergency guy would be given preference. Now your call would be rejected. Your radio connection would be rejected. Possible. Next. So this is the request message. If you send a request, network will come back to you either positively or negatively. We see the positive case later. First, we see negative case, reject. If network is rejecting it, network tells you that I'm rejecting it, man. You are allowed to re-trigger the RRC procedure once again, but please wait for this much amount of time. There is a rejected time indicated in seconds. Maximum value can be up to like, 32 seconds or 16 seconds. Some value is possible. So one of the number will be chosen, some number of seconds. Network tells you, hey, you have to wait for this much amount of time, and after that you can reattempt your RRC procedure. So when network have to prioritize the subscribers and reject some subscribers and accept some guys as part of user access control mechanism, or GNODB to reduce its load, it would be rejecting some radio connections and asking the mobile equipments, don't attempt the connection for some number of seconds. Now, that is the negative part. What about the positive part? If network is accepting your connection, then network would send you RRC setup. So what details would be there present in here? So a lot of configuration would be there. RRC setup. First, it will contain a transaction identifier. Normally, the transaction identifier value is from 0 to 3. One of the value would be chosen. Typically, 0 would be chosen. When multiple RRC transactions are going on for a single subscriber, used as the transaction identifier. So this is to separate, differentiate between different procedures that are parallelly occurring. Okay, next. RRC setup IEs that will lead to here that contains radio bearer configuration. Now this radio bearer configuration will contain details about, so that radio bearer configuration we have here. How many radio bearers network is configuring? Normally these radio bearers that are configured during RRC connection, only SRBs will be configured. SRBs add modify list would contain, DRBs to add modify list or release list won't be present at the starting itself. Our security config won't be present at the starting. Our MRBs, the other things we are not studying, SRB4, etc. are required in advanced things, are dual cases, we are ignoring them for time being. We ignore them. But even if we ignore these things, why DRBs won't be present along with the radio connection? DRB means you are sending, you are given permission to do the data transmission and data reception, uplink data traffic and downlink data traffic. For that, GNODB don't have permission to allow these DRBs on its own. Mobile equipment must go and speak to the AMF, SMF, etc. and convince them to provide this service. Only once AMF or especially perfectly speaking, only once SMF comes to the GNODB with the QoS profile, then only GNODB will be triggering the creation of the DRBs. So this DRB to add modify list would be optional, not present. So they are not required. During the radio connection, these are not required. Then you can ask me, hey, why is there then? If they are not even required, why they are present as optional? They would have removed these packages right from here in this message. Why it is present? Because this radio bearer setup message, it can be present in various RRC procedures. like RRC reconfiguration procedures also, this package can be present. As part of the reconfiguration, network is allowed to configure the DRBs. At a later stage, reconfiguration will happen. After original configuration, reconfiguration happens. So during that reconfiguration, these packages can be present. So that time they need to be there. This time they would be absent. This time they are optional. Next time it will be present in the next message when the same package is present in RRC reconfig. So now we are going to expand this package and study the deeper details of this package. But remember one important thing. Whatever we are studying may not be directly be applicable during the RRC setup. You have to remember that. That is very, very important. So we are studying this radio bearer config generically that may be applicable in the other situations also. So you have to realize that point. So what is present inside SRB to add modify list? What details would be there in that SRB to add modify list? So it contains a list of SRBs that will be need to be added or modified. But of course, during the starting only it can be added, cannot be modified when you are coming up with a radio connection. Later they can be modified. Already created SRBs can be modified to change the configuration. But it is called as the add or modify. Now in that add or modify, you will have details about what is the SRB identity, which can be either one or two, only two SRBs in this case. Later 3 and 4 came later. And as part of this SRB, are you re-establishing the PDCP, or are you discarding the PDCP things? Discard on PDCP is enabled or not, true or false. But these things only during modification they will occur, they won't happen during adding part. They happen only during modification. That happens later. But they're talking about the PDCPs to be re-established or discarding of the PDCP is getting enabled or not. Re-establishment means PDCP need to reset the sequence numbers and restart its operation. Especially during any failure cases or handover cases, it can happen or it may not happen depending on the configuration. PDCP config. You have ID here followed by PDCP config. That PDCP config will contain the details of PDCP protocol layer, how PDCP should work. So this package we have already seen in the at the PDCP protocol study. If I have to show you that PDCP config, that is not part of the document now, but I'll show you that PDCP config once. It's not present here as such. Okay, as you can see here, this is the PDCP config. What details would be present here? So discard timer, PDCP sequence number size in uplink 12 bits or 18 bits, or in downlink 12 bits or 18 bits. Header compression is enabled or not. This configuration is applicable for DRB. But if it is SRB, you will have it in the below. Okay, it is not there. So if it is not there, so PDCP config is almost not present for SRBs. It must use default configuration. whatever that is present. Because in this particular list, there is no information related to DRB part present in the PDCP config section. So this is applicable, this PDCP config that is present here is applicable for both DRBs to add modify and as well as SRBs to add modify. But SRBs to add modify is almost blank. There is nothing specially provided because already how the PDCP should work, there is a default configuration that is already available for all the SRBs. So SRB1, SRB2, SRB3, PDCP config only one parameter that is set to infinity. Remaining all the parameters might have been set to static values, static mechanism. So you don't need to provide those details. But that is SRB to add modify containing PDCP config. DRB to add modify contains SDAP config. SDAP is not part of the SRBs. SDAP is only part of DRBs, data radio bearers. We have studied that multiple times. If you remember this thing, you'll know. SDAP would be present only with the PDCPs that are dealing with the data PDUs. It is not part of the RRC, above PDCPs that are working for RRC. So in the DRBs to add modify, you have SDAP config, DRB identity, PDCP config. But in this time, PDCP config definitely will contain all these details that we have seen here. Like header compression is enabled or not. If it is header compression is enabled, which ROHC profile has been enabled, and is it only uplink or uplink only ROHC or both directions, and what is the T reordering, and whether the ciphering is enabled or disabled, Ethernet header compression enabled or not, and if your user data compression is uplink data compression is enabled or not, or data compression is enabled or not. If it is Ethernet header compression, like the context IDs that we can create for the Ethernet header compression, how many context IDs you can create, etc., etc., etc. So related to their operations, PDCP config. SDAP config will have SDAP related configuration details. So if I go here, so in the bottom part, you will have SDAP config. It is not located. Let us search for that again. This SDAP is part of which PDU session? SDAP header in downlink is going to be present or absent. SDAP header in uplink present or absent. Default DRB, is this a default DRB or not? If that DRB that is coming up right now along with the SDAP. What is the mapped quality of service flows to add? How many QoFIs are part of it? Or how many QoFIs are getting released from this particular QoS flow, from this particular DRB configuration? In a DRB, you can carry multiple QoS flows. First, you have to add the QoS flows. Later, if you are during the modification, you can release them. You can release some of the QoS flows. At that time, you will be sending something. You would be reporting end marker, if you remember. So QFI IDs, PDU session IDs. One PDU session for one data network, corresponding details. Security config. Security config will contain security config algorithm details. That security config details will have encryption and integrity protection algorithm numbers like EIA0 or EIA1, etc. That information will be present, and which master key to use or secondary key to use. That details are present in the security config. And MRBs, we can ignore MRB part. Time waste. Now, I have showed you DRB to add, modify, or DRB to release list, which I did DRB to be released. But these things will happen once mobile equipment is already active and started exchanging the user traffic in both the directions and already created the DRBs. DRB can be released. DRBs can be added after the security has been enabled. These things can be there. But remember, even though I'm showing you all these things at once, these are not part of our procedure that we are studying. Which one I'm talking about? The setup procedure. In these things we studied, but these are not part of our RRC setup. They are optional. They'll be ignored. These are present again, once again, in some other separate message where the same radio bearer config package would be present separately somewhere else. During that time, this would be present. These things would be present. The DRBs that we need to add or modify or release or the security configuration related to it. But none of these packages would be present as part of RRC setup. Next, in this RRC setup, not only you get radio bearer related configuration, you get this master cell group config, in which you have a package called a cell group config, which will contain the lower layer related details, like it will contain the RLC configuration, it will contain logical channel configuration, it will contain MAC configuration, it will contain physical layer configuration, etc. And what is this master cell group? You can have multiple cells. The primary cell is called as master cell. Secondary cells are also can be present. The secondary cell related linking will be there inside this again, if required. But during the RRC setup, you will not have that secondary cells. But you have only master cell as that will be present as part of cell group config. I'll show you the cell group config also. So in this cell group config, you will have RLC bearer to add, modify, RLC bearer configuration, and it will contain logical channel ID, and it will also contain MAC cell group config, MAC related details, like when you have to send the buffer status report, when you have to, when you can expect the timing advance, etc., etc. Physical cell config, physical layer related configuration. If you remember, RRC's duty is to configure all the lower layer related operations. Now you can observe how it is happening here. So you are getting RLC configuration, logical channel configuration, MAC configuration, physical channel configuration. And each one of it is a big package in the messages. Each one of it. For example, if I take you to this RLC bearer config, which is a sub package, you will contain RLC related configuration details. So you have what is the logical channel ID that is associated with that RLC, and is it working for a SRB or a DRB, and if during the reconfiguration RLC will be advised to reconfigure, this will be set to true. But if it is not a reconfiguration, it is the first time establishment, then you will have the RLC config present and plus logical channel config present. So what does these RLC config and logical channel config details will contain once again? So if you go to the spec, so you have to look for RLC config, in which you will have details. Is it a AM mode RLC that is getting configured, or UM mode bidirectional RLC, or UM mode unidirectional RLC only working for uplink, or UM mode unidirectional RLC which is only working for downlink? Now again, if it is AM mode, so again, AM mode uplink properties. What is the size of the sequence number when you have to retransmit if the polling PDU is not responded back with an acknowledgement or status report? What is your poll PDU size? What is your poll byte? How many times you are allowed to retransmit, etc. Different parameters. And if it is downlink AMRLC, when you have to apply the reassembly timer, and after transmitting the status report, how much time you are not allowed to transmit the status report once again, T status prohibit, and so on. Similarly, AM mode sequence number length for uplink and downlink, and when what is the T assembly timer for UM mode in downlink, and each timer value, one of these values will be picked up. Poll retransmit, one of the value, for example, seconds is to be picked up. Every after sending the polling PDU, if you did not receive the status report even after 350 milliseconds, you will automatically send the polling bit to 1. So you will send the polling PDU once again. Or poll PDU. Every, for example, if it is set to this value, every 32,768 packets once, you will be requesting for the polling or status report. Or if poll byte is set to 1500 kilobytes, every 1500 kilobytes once, you will be requesting for the status report. Similarly, T reassembly, the other field values. So the complete RLC configuration is arriving for you as part of this RLC config. As part of logical channel config, you will have details about prioritized bitrate, etc. Your logical channel priority and so on. I'll show you that also. What is it? Logical channel configuration. So what is the logical channel's priority? 1 to 16 value, prioritized bitrate, PBR, bucket size duration. So we learned that every bucket size duration, you have to empty prioritize bitrate amount of data so that you can achieve your GBR, especially in case of GBR specific logical channels. If the logical channels are not GBR specific, then these things will be absent. These things won't be there because this whole package is optional. A lot of other details. This logical channel belongs to which logical channel group to report your buffer status report. What is the scheduling request configuration available for you to send scheduling requests every now and then to request for the uplink resources? When you don't have enough space to send BSR, you would be using scheduling requests. That scheduling request related ID, that ID will be linked to PUCCH resources. We have seen that in the PUCCH. Like that. So you have all your lower layer related configuration being sent to you. But so that are part of this radio bearer, RLC bearer config. As part of it, you have the details. But if required, additional cells can be configured as well, which we call as secondary cells, etc. as part of the cell group. We'll ignore all that for time being. We are not learning those concepts, secondary cells and what is that? Every cell that you are configuring will have the same details replicated, because for every cell you have the same configuration required to make the mobile equipment operate in multiple cells parallelly at the same time. So if you go back, so the cell group config containing all the lower layer related information, including the physical layer parts, which I haven't even showed you, but that is also present there in that packages. So as part of the RRC connection setup, you will get the needed lower layer configuration as here. Radio bearers are lower layers details, which mobile would be configuring. And from then onwards, mobile will have to use that configuration that is provided. Next. So if it is a RRC connection, RRC setup that you have received, which is a successful acceptance from the network, that it is accepting the radio connection, mobile equipment will send setup complete. In setup complete, mobile would report it'll report its happiness first of all with these IEs. Hey, which PLMN I have selected for my operation? Plus, if I am already registered with the AMF, then I'm going to provide my AMF details. If you are not registered, that is kind of optional. You will ignore it. If this is the first time you are attempting the connection, you are not registered earlier, that won't be there. And the AMF ID would be sent. Basically, this GUAMI is also related to this AMF. GUAMI is AMF ID only. But what is the AMF type? It is native or mapped. I'm not going into those details because we are not studying core network much. We are ignoring that part. Yes, NSSAI list also I'm ignoring. It is related to slices. So it's called as a network slice ID. I did not teach you network slices. We are ignoring. But the most important part in this message is the dedicated NAS message. So this is the first message that the mobile equipment is trying to send to the core network by packing it into the RRC connection setup complete, which is being sent to Gnode B. Gnode B extracts this NAS message out of its body and it will pack that into it'll pack that into a NAS. It'll pack that into a NGAP message, forward it to the core network. That is that. So we have mobile ID, or whatever the mobile ID is there. It will be packing that mobile its own ID here in this message. Setup complete. STMC, if it is available again. But this whole package is optional. If mobile is did not have any ID present, STMC allocated by the core network present, it will ignore this. Critical extensions we can ignore. That is for the futuristic part. If any additional information is needed, we are ignoring it. Just like I have told you earlier. So you have release 16 contains additional IAB related parameters or UE measurements if they're available. If mobile equipment is reporting that I have idle mode UE measurements available, or if UE is maintaining its location related history, it is reporting that I have mobility history available to the network. So, and also mobile reporting to the network that I am a normal mobile phone or a medium mobile phone or high speed mobile phone, medium traveling mobile phone or high speed mobile phone, depending on it, etc. These are additional details in release 16. Then the non-critical extensions will have release 17, which has got some onboarding, which is again related to IAB. We ignore that. Again, some additional parameters introduced in release 17. Okay. So that is the overall radio connection procedure. But once the radio connection is established, that connection won't be maintained as it is like that. It would be reconfigured. Normally during RRC setup, even though I have showed you DRBs and all the logical channels and their prioritized bit rates, etc., all those things won't be present in this message. Only SRB1 related and corresponding configuration would be present at the starting. Even though that big package is there, all the optional parameters will be ignored. But later, when mobile is taking to the next step, when the SRB2 is getting created or DRB is getting created, that time definitely all those additional details which I have showed you would be present in the corresponding procedure. My voice is lost for a couple of minutes. I did not speak anyway in that time. My audio device got switched off, changed the audio device. I hope now you can hear me. All right. Can someone confirm that it is audible so that I can continue?
Yes, sir.
Yes, sir.
Yes. Okay. So as part of this procedure, security mode procedure, network sends security mode command to the UE. So before configuring the SRB2 and DRBs, network will always do this job. Security mode command. It'll have to enable the security for sure. Now, mobile equipment can either respond back with security mode complete or failure. If whatever the security algorithm that the network is proposing, if are not available with the mobile would kind of reject it. Otherwise, mobile would accept it. It is not EUTRA, actually it's copy pasting problems from LTE. So it is GNODB, or we can simply consider it as network. So what details would be there in security mode command? Security mode command contains security mode command IEs that will contain security config SMC, that contains security algorithm config, that contains ciphering algorithm and integrity algorithm. So you have the ciphering algorithm, you have the integrity algorithm. So which integrity algorithm is getting enabled as part of your PDCP procedure? Which ciphering algorithm is getting enabled? One of these four algorithms, one of these would be chosen by the network. By accepting, network need to provide reply back to the network. It sends back security mode complete. It tells the network that, hey, thank you very much for enabling the security mode, and I'm really grateful for you for doing this. Okay, so for enabling the security for me. By using the keys that are available for me, I will be encrypting the messages and I'll be calculating the MAC-I message authentication code for integrity protection. It is sending a happy complete message, which is containing nothing actually. As you can see, the message is very small. It's all containing all blanks most of the times, blank sequences, not much of the details present in it. But if network proposed any security mechanism that is not available with the mobile, for example, then mobile will always have a choice to reject that security mode procedure by sending a security mode failure, which also doesn't contain much of the information in it. Almost all the parameters are dummy, but you will send a failure message. When this failure message is received at GNODB understands that, okay, mobile may not be having the algorithm that I might have proposed, so I have to choose and pick maybe other algorithm by finding out what is the issue. Most of the times it will be avoided, but for any reason, if the network mobile equipment cannot activate the security, it will send a failure. But once send a failure, you cannot create SRB2 and DRB, not allowed. So to go for SRB2 or DRB creation, it's mandatory that this is successful. Only after the security mode is successful, your mobile network will send you a message to create the required, required SRB related information, SRB2 or DRBs related configuration. It sends you. Now, assume that security mode procedure is successful. If security mode procedure is successful, after that, mobile can kind of sending NAS messages separately in SRB2. It can send the NAS messages in either direction. Network can send you downlink information transfer, wherein it can pack a NAS message inside. So it's in this downlink information transfer, you would be having a dedicated NAS message as part of its IEs. This would be sent on SRB2. Once SRB2 is created, it must be sent on SRB2. NAS messages must be exchanged on SRB2. But before SRB2 creation, if any NAS messages need to be exchanged by using this message called as downlink information transfer, it is a special RRC message just to for the purpose of carrying a NAS message. That's all. It doesn't do any other job. This downlink information transfer. Its duty is to carry a NAS message in it. That's it. But whether we have to send it on SRB1 or SRB2, till SRB2 is established, we can carry it on SRB1, that is allowed. But if SRB2 is already established after enabling the security, then these downlink information transfer messages, which are called as pure NAS messages, they must be always traveling on SRB2. That's the mandatory condition. This IAB, DU, F1C, etc., we'll ignore. Those are dual cases. We are not studying them. So network would use SRB2 to send the NAS message it is getting from the core network. For example, if AMF sends any NAS message to Gnode B need to forward that to mobile. Gnode B uses SRB2 once it is already created. If it is not yet created, it can use SRB1. Similarly, uplink mechanism as well. If mobile want to send any uplink NAS message to the core network, so it will send in this, uplink information transfer message. Oops, the message is missing. That's bad. So this is the uplink information transfer message, which is containing IEs and containing the dedicated NAS message. When it is sent from the mobile equipment to Gnode B extracts this NAS message out and it will pack into NGFE protocol and send it to the AMF or SMF. It starts sending it towards that. But there are several types of uplink information transfers related to V2X, etc., which we are ignoring. We are only studying this one uplink information transfer that is applicable, sent by the mobile equipment while sending the message in uplink direction. Next, one last message, UE capability transfer. What is it? Sorry. I think I did not. Okay, I'll do one thing. I'll add up that the old links are not removed. I'll add up that in tomorrow's session. Anyway, we have to continue this part. Still handover related and additional DRB related things are not completed. Along with that, I'll show you that message. Okay. I think I did not make correct modifications in there. I've done the material in a hurry. Okay. So with that, we have completed today's session. So today we have mostly discussed about how RRC connection is established and how the